want the students to interact with Professor Wuthrich. You can ask any questions. So one of the things we are saying is that the faculty can now excuse themselves, Mr. Wuthrich, because usually when the faculty are around, the students do not feel very free. So we want them to interact with you. So
I see. Well, I noticed that this is a frightening bunch of professors.
Okay, so you please carry on with the students. They feel more comfortable.
Yeah, but I need some help.
Yes, yes. Professor Chandrakumar will be here.
Why don't you stay? I think it's better if we. I also okay. Okay, you get this going. Okay. Nice to meet you.
Because the number of you youngsters have joined in just the last few minutes here, I would, with the permission of Professor Wuthrich, spend a couple of minutes formally saying a few words about him. One doesn't need to say much about him at all, but for the sake of youngsters, just mention that words you know very well, the unique recognition he won in 2002, Nobel Prize in Chemistry, for his great advancements in biomolecular NMR by novel methods which he devised and his group devised, which then were successful in putting out exquisite details of complex biomolecules. For the sake of the younger community, I would mention that if you look at the history of magnetic resonance, investigation started with molecules of the size of 18 Dalton, water, maybe 150 Dalton, wax. And then it went on at the hands of his own great friend and collaborator, including Professor Richard Ernst, to, let's say, the ballpark of about 5 kilodalton or so. But then it was left to the unique hands of Professor KURT Wuthrich to take it all the way to well in excess of 100 kilodalton. And that's what makes the key difference to the way one might be tempted to use NMR to look at structures. Also, for the benefit of the youngsters, I would like to mention the following. I will not repeat this for the seminar introduction. I just want to say the following. Nuclei are little things in as far as their magnetism is concerned. And nuclear spins, in the words of Anatole Abraham, who wrote this masterly treatise on nuclear magnetism, you know, he has a header for each chapter, and one of his chapter headers says in French, "On a souvent besoin d'un plus petit soi," which means, roughly translated, that even biggies often need the help of the small guys. So the nuclear spins at these small guys, and people are constantly surprised at what these small guys can do for the big problems. So I think Professor Wuthrich has recorded in his Nobel lecture, for example, when he set out, and by the way, also for the youngsters here I should point out, the siren of the magnetic resonance community, if I may put it that way, is electron paramagnetic resonance, because they are much stronger, the electrons, with their magnetic moment and those properties there for magnetic resonance by way of EPR. Professor Wuthrich himself started with doctoral work in the area of transition metal complexes, looking at EPR, then going on to look at relaxation studies by way of both NMR and EPR of, let's say, aqueous solutions and solvation properties of transition metals again, before he went into the proteins proper. And when he got into proteins proper, I think he spilled his own blood, because I have read it in his Nobel lecture that the first studies he performed were actually the hemoglobin sample extracted from KURT Wutthrich's blood. Am I right, Professor? Right. So he went into NMR by way of EPR, if I may put it that way, from the stronger magnet to the weaker magnet, as it were. But then, as I said, on a swarm was when the primitive swarm. So the small guys have turned out at his hands to prove enormous insight into just about the biggest of macromolecules that one is currently concerned with in the area of biochemistry, if I may put it that way. Now, it has been at his hands that a large number of techniques are powered, And every once in a while, magnetic resonance and NMR in particular has turned out to be evergreens. We all think, okay, everything is known that is to be known about this field, and then up comes another. So when he first, as he has recorded, we used to, as students and as young scientists in my, vast past, young years, we used to call him an NMR fanatic. The reason we called him an NMR fanatic was that, correct me if I'm mistaken, but he did the unique thing in the mid-80s of completely solving ab initio without using any other technique, the full structure of proteins by NMR and NMR alone. And he has recorded how NMR was tolerated by them as something which can be interesting, a little play tool as it were. And he has recorded also the kind of skepticism that was met when it was first proposed largely at the hands of his group, that serious information about protein structure could emerge from NMR studies, from this little thing, this little play tool. Okay? I won't say much more than that. The rest is history as it were. And with the short introduction to Professor Wuthrich and his exploits, which I hope will certainly prove to be very encouraging for youngsters in this group, I would request Professor Wuthrich himself to make a few opening remarks, and then maybe Professor Sankaraman would like to add a little bit, and then I will throw it open to the students.
Well, it's a pleasure to see you all here. You are the future of your country. You are going to carry the ball long after us. And so we, of course, count very much on you. Maybe as an opening remark, I could refer to an observation that I have made with quite across the board with postdoctoral fellows who joined my laboratory after getting a PhD within India. And that observation is that, say, these postdoctoral fellows would know a given technique, they would learn new techniques under supervision, and they would use what they have learned, but the problems tend to arise whenever they meet something unexpected. Then they are usually lost, may even stop to work until they get advice on what to do next. But it is something that I have noticed. Really, I'm not talking about the statistically relevant sample. I have had about 20 postdoctoral fellows from India, but this is a very characteristic trait. Now, on my own, I would always orient myself as to think, am I now doing something that nobody else has ever done before? It's the same amount of work as if you repeat work that has been done by others. And this is maybe the most important message that I can give to you on a quite general level. You should not be satisfied with knowing and being able to use the technology, but your real contribution comes when you meet the unexpected and have to face the solutions to a completely unexpected novel problem that arises in the course of your work. And with this, I think I don't want to give a longer speech here. I hand the mic to you, but it should be up to the students to...
Primarily this session is meant for interaction of the students with our distinguished visitor. So I would encourage the student community to ask whatever the questions or doubts or whatever you want to ask the Nobel Laureate, for example. This is your opportunity. Please, welcome you to do this. So who wants to initiate the discussion? Yeah, good.
Sit down. Introduce yourself first, and then you can My name is Ranjit Rai. I did my MSc from IIT Madras only, and now I am working under the guidance of Dr. Dilip Kumar Chand as a project staff. So my question is like for researcher. I have heard from my seniors, from my friends, that what is the most important factor in research? Then very often I come across the word attitude. So sir, I would like to can you please elaborate? Attitude means what attitude and what type of attitude?
Attitude is a key word. Well, I think that goes very close to what I mentioned just a minute ago. Attitude is to be open to challenge the unexpected. See, once you have obtained a PhD, your contributions should be to create something new. And I think that's a matter of attitude.
Thank you.
You move to the next question. We'll pass the mic around.
Sir, I wanted to ask.
Introduce yourself.
Yeah, my name is Bhartendu Kumar Srivastav. I am working in a bioorganic and medicinal chemistry lab here. Sir, how to avoid frustration in research?
How do I?
Avoid frustration.
Avoid frustration.
Frustration.
You are frustrated? You don't look that way. You look.
Maybe in some of the phases, everyone will be first frustrated. We are not getting results. We are trying and something like that. So how to avoid that sort of frustration? Means you have worked more than 70 years in this field, so you will be knowing some techniques.
Well, you see, how old are you?
25.
Okay. When I was 25, I already had my PhD. So I have to talk about earlier years. I would do sports for about 6 hours a day. And only after having done sports enough, I would go and do some research. So it's very special, you see. I have a university degrees in sports. I was professional in sports, and I did scientific work only in the evenings, essentially, at the time. And as was mentioned, the first major works that I did was studying my own blood. And I studied my own blood because I hoped that it would help me with my performance in sports. You see, oxygen consumption is a key element in endurance sports. I don't want to go into this very much, but most of doping in sports today has to do with so-called blood doping. See, and that started when I was your age, or a little before. And so I didn't have a problem in the sense of frustration. You see, when you are in sports, you can't get frustrated. You have to accept defeat, and you have to train harder to overcome defeat. And then when I did these studies on my blood, this became so important that I was reasonably successful then at a very early age in science, all of a sudden, unexpectedly. And so the periods of frustration for me have not been very frequent. And I didn't study this. You see, being in research is such an exciting thing. It goes to the previous question about attitude. You have to be prepared for the unexpected. You are here to solve difficult problems. See, it's not worthwhile to work on an unimportant problem. You want to work on difficult problems, and so it's a matter of attitude to overcome moments of doubt. I would not talk about frustration. I would talk moments of doubt. See, let me give you a very direct example. Say, if you play soccer, I mean European football, and you score a goal, that's immediate fame. Okay? If you kick a goal in a high league in football, you are in the newspapers the next day, probably with a photograph. If you have success in your scientific research, it may take 10 years until it's recognized by others as a success. See, and one of the important things is that you yourself have learned to decide whether or not you have done something important. Even if the others don't believe you, in particular if they don't believe you. You see, that may give you frustration. The others criticizing your work. The more they criticize, the higher is the probability that you have done something important. You see, having this sort of thinking helps you overcome such moments of apparent frustration.
Thank you.
Good morning, sir. I am Akash Gupta, working under Dr. Ramesh Gardas in Solution Thermodynamics and IIT Madras.
In thermodynamics.
Solution Thermodynamics.
Mm-hmm.
My question is essentially concerned to your research. Is there any method or historical account for describing some phenomenological relations by account of NMR? Like a fixed relation is there, or some future perspectives are there by use of NMR we can have
Today.
such type of phenomenological relations we can reduce.
Well, are you really asking me, is there still a future in doing research in NMR?
Yes. Some phenomenological relations we can deduce on the basis of NMR experiments.
Where you expect NMR to throw light on some phenomenological,
Yeah.
phenomenologically significant issues.
Yeah.
Yeah, and what are you thinking about? What do you see? We can now use NMR to solve structures of complicated molecules. There are more than 10,000 protein structures deposited in the protein data bank which have been solved by NMR. There will be many more. The number is rapidly increasing. But maybe I should answer your question in the following way. If you study NMR today, you have a very good chance professionally to make a career. See, today in India you have a very low number of magnetic resonance imaging devices. Yet, you know what I'm talking about. I'm talking about clinical use of magnetic resonance imaging. And it is to be foreseen that a couple of thousand or more MRIs will be installed in India during the coming decades. Well, then you'll have a situation that's comparable to what it is today in the United States or in most countries in Europe. And there will be thousands of jobs for people trained in our field. I think that's one of the reasons, one of the ideas that I can give to you. And the second is that as long as you work in the laboratory, you are bound to make new findings, new observations, to shed new light on phenomena. There is no other way. As long as you do experiments, you'll find something new.
Sir, one more question. What was the motivation that you had that hold you to the Nobel Prize, to get that prize?
I didn't decide on this. So others decided. You can't work for a prize. You see, there is no clear set of rules on how you how you can get a prize. I think you just have to be curious, find something new, and on the long run hope that the community will acknowledge that your work has been special. And of course, you see that you can tell after a while. You see,
what specialty one should find himself to stand like you?
Sorry?
What specialty one should find in himself to stand like you in some research field? What much more significant thing is there?
Well, one way you can judge significance is that we solved the first structure of a protein by NMR in 1984. Today there are 10,000 structures. Okay, then there must be something significant behind what we have done. Or we used to be a very small group of scientists working in my field. Today we may have congresses with thousands of participants. You see, that's how you can get an impression of the impact that one's work has had. And then of course you have all these analysis of the publication records and the impact of the publications and books. But when you do the actual work, you cannot think about this. You just, in my case, I think I was reasonably naive. I was just very curious, and there would be people who said it will never be possible to solve a protein structure except in crystals. So I said, well, if it's impossible, then I have to do it. You see, it is this sort of attitude.
You pass the mic to
Thank
the
you.
next, please. Thank you.
So my name is Bhairu Benke. I'm working on peptide nanotubes. So how much freedom you give to your PhD scholar to work on their own idea?
How much
Freedom.
freedom did I have in my PhD?
Students to work on their own idea in 4th year or 3rd year.
Freedom do you give it to your students to work on their own ideas?
Well, I let them do. You see, they have a lot of freedom because I'm traveling. Okay, right now they have a lot of freedom. But when I come back in Saturday a week, a week from tomorrow, they have to deliver a written report on what they have done since I left. And depending on what comes out in this report, they will have more or less freedom during the coming weeks when I'm back home. It depends. You see, in principle, on the level of PhD studies, a scientist should be able to develop his own work on a daily basis. But there is also one one of the important things for me in this whole game is to make sure that the student does not reinvent the wheel. Do you understand what I mean? You see, there are so many things that have already been done. And if I, long ago maybe, and if I discover that the student is embarking on finding something that you can already see in the literature, then I of course have to step in and make sure that he reads that literature and instead of repeating what has already been done, goes into something new. But on a daily basis, the students are entirely on their own. See, I have different jobs around the world, and my students are always alone again for weeks at a time. And if they don't know how to go on a daily basis, then they cannot work with me. Then they'll be lost.
Good morning, sir.
There's only about 2 more questions because the time is coming up for the seminar. So just the last 2 questions. And after you
Well, I think that should be the last one if I see the time.
Okay. But with your permission, I would like to offer the opportunity for 1 question from this side of the hall as well.
Okay.
But first you.
Yeah. Good morning, sir. This is Pratap. I'm doing my PhD here. So, my question is, so what is the most memorable moment in your life during the research, and what is the message you would like to give it to us today?
Well, you see, I'm an old man, and so I have had many big excitements in my life, and I wouldn't want to single out a given one. Certainly not getting a prize. Okay, that comes much later. The excitement is when we find something truly novel. You'll see, I'll mention a couple of things that were truly novel in my lecture, which is now coming up. You'll see, I tell you one, when we found out that aromatic rings inside big molecules are not static but flip all the time, that was amazing. Not only for us, and everybody was amazed. You see, and this was one of those high moments. And of course, having finished the structure determination was. But there were others. You see that, I mean, the invention of Drosy, for example, which you mentioned, where all of a sudden we beat the size barrier, and instead of being limited to studies of molecules with molecular weights to about 20 or 25,000, we all of a sudden could do it for 1 million size, you see, just having done the right physics. These are moments. The prizes come later.
Okay, 1 last question with Professor Wuthrich's permission from a student, maybe on this side of the hall, because there have been very few from here so far. 1 last question.
No, they don't want to, you see.
Maybe from the other side of the hall. Anyone? Any taker for 1 last question? Okay, that's not a student, but Professor Naik also from Orissa. Please. Please go.
What is your perception of life?
My
What is your perception of life?
perception.
Perception of life as a whole, being a scientist of this repute. I think your statements would be of tremendous help to our students. So I'm asking you as to what is your perception of life as a scientist of such a repute?
Perception of life. Why are you alive? Is this what you asked me?
and has a typical, metaphysical bent.
Well, I mean, my perception of life is that it's all based on chemistry,
So
physics.
is life science? All about life is science? Or do you think science is just an arena of life?
Now, maybe I misunderstand your question. Are you asking why do I think that I'm alive? Why can I move my finger?
In any way you'd like to interpret it.
Yes. So I believe that in the end we will, maybe not we, but coming generations will be able to understand all of these things that are part of life based on interplay of molecules, the physics and the chemistry of interplay of molecules.
Thank you very much, Professor Wuthrich, and thanks very much for the audience for your participation. I'm sure there are young people who would still like to shoot their mouths, but all good things must come to an end, because next is the technical seminar of this department. Professor Wuthrich is also to give a public lecture later this evening at an ICSR auditorium starting 5 o'clock. But that's a public lecture, therefore it's for a different kind of audience. This one is a technical seminar on the core, perhaps, of his work, which we'll try to share with us in NMR for protein research, let's say, in a broad sense. So we will just adjourn for that for a few minutes while we get the talk ready. Thank Professor Wuthrich and also the audience once again for your very lively participation.
Yeah, where is